Hello everyone, and welcome back to this next video in the Houdini Academy Foundation module. In this video, we are going to cover the last topic of the Foundation module, where we are going to restore our Houdini preview material, which we removed in the last video. Now, our materials still work in Unreal, as they are Unreal material attributes, and they are simply grabbing the material from our materials folder, right? However, since in the last video we removed the QuickShades from our texturing utility nodes in order to optimize our network, we no longer have materials assigned automatically with our UVs. We do actually have UVs on these models. As you can see, they are in here. However, we don't have them visible because we don't have any material being loaded into memory, and it's also not assigned to our primitives. So in this video, we are going to create a new system that can reassign these materials for our Houdini preview at the end of our network. And luckily, we did keep around the file path for each of our materials as a series of attributes over here. We have the Unreal material, which Unreal is using to grab the correct material from our material folder, but we also have the preview material path here, which, if I expand this far enough, contains the entire string for our file and its folder on our hard drive. So we can load for every single primitive its assigned texture. Now next to that, we also created a preview material name output here, which in this case is trying to assign this texture, which does not include the folder that the texture is in, but it does contain just the file name on its own. Now we can use these to reassign our materials. But before we can do this, we are first going to have to cover a little bit about how materials in Houdini's viewport are handled, and why we can't just stick a QuickShade into a Foreach loop and then have it load all the materials on our building. Because that would be the easiest, right? Just one QuickShade in a Foreach loop would do it. Well, that doesn't work. And I do want to quickly cover why. And next to that, we have to deal with a bug in Houdini 18.5, which doesn't allow materials to be loaded using a live file path attribute like this one over here. Unfortunately, if we try to use a material node like a QuickShade to assign a texture back onto our mesh using an existing attribute, that's going to cause a corruption glitch in Houdini 18.5 that will cause several of our loops to stop working. This will then have a knock-on effect through the way how Houdini handles memory, and over time it can cause Houdini to become unstable and crash, probably sooner than later. So for this video, we are going to avoid creating a direct file path link. So we are going to create a dedicated texturing system that works in Houdini 18.5, which is going to be a bit more hard-coded. However, it will still work. Basically what we're going to do is, instead of assigning it from an attribute, we are going to use an attribute to create a group. So we are going to have some groups on this object here, which for each one of our primitives describes which material it should load, and then based on that we are going to load the correct material, which is already pre-configured, onto the corresponding parts of our mesh. So we're basically going to assign a preset material onto our mesh using our groups. Now that's simple enough. However, it does mean that since we are assigning our materials over here already in some of our texturing assets, this hard-coded system is going to mean that every single time we make a change in some of our texturing assets, like over here, we also will have to update it in here. So that means we have to update it twice. And that's not automated, that's more manual. And that means we can make mistakes and introduce bugs, right? That's not a great way of doing things. However, I am going to make it easier on us by creating a group-based assignment system. So if we already have a material that's being assigned, then it will pop up here in this dropdown and we can easily assign it onto our building that way. Now to pull this off, we are going to use a bit more vex. We're going to have to take our preview material name attribute here, which is basically the file name of the texture we're trying to load without the folder in front of it. And then we're going to take that, remove its extension, so in this case that would be remove the .png from this string, and then we're going to turn that into a group. So that allows us to then reference both the texture and the group to one another, and that will allow us to assign it. Now to do that, we are going to have to cover a bit more vex code, including a couple of array operations, including the split and the join function. And I will cover what arrays are in Houdini in just a moment. And then we're also going to have a look at encoding and decoding strings, which is not exclusive to vex, but what this basically does is it allows us to take a string and take any special characters like question marks, dots, or exclamation marks and convert them into something that can be used by a group. Now we'll cover more about this later, but what we'll use it for is down here, these subnets, which are basically just duplicates of one another, but each one is assigning its own material. So we have one for each material we are going to assign in our tool. Now this interface is going to be simple enough. So we have that drop down in here, and that's going to assign a group. We have a folder and we have the extension for a file. So we're going to have to configure this. Then inside we have a QuickShade node, which is simply taking that folder structure, the group name, which it has to decode to make sure it gets the right naming format, and then the file extension as well. Plus we make sure we assign it only to the actual group we want to assign it to, which in this case is the actual file name, right? So you understand what I'm trying to do here? And if you don't quite get it yet, don't worry, we're going to cover it in this lecture and we'll get to it. So in this video, we are going to avoid creating a direct link to our texture file path. While this is less flexible, and it means we have to ensure we set our materials up twice, so both in our utilities and then down here, it does avoid this memory corruption glitch in Houdini 18.5, which means our tool won't be crashing Houdini, right? That's important. However, that doesn't mean we aren't going to try a more automated approach. But to make that work, we are going to have to use Houdini 19. Now, when side effects created Houdini 19, they actually updated the way how Houdini deals with materials and how it deals with its memory. So in the next video of the foundation module, we are going to update to Houdini 19 and also its Houdini engine install as well. And if you haven't done so already yourself, I will show you how to do this with some useful tips and tricks on how to migrate your current 18.5 project to Houdini 19. And then once we've done that, we'll recreate our material reassignment code for Houdini 19, so it's more automated. So we're going to recreate this system here. I'll also cover a little bit of extra vex, so you can actually write a system that will check if your files exist or not. So if they don't exist, we can actually load a different material. In this case, that would be our UV gray texture that comes by default with Houdini. So basically we get this texture if a texture doesn't actually exist or we're trying to load an invalid one instead of something blank. Alright, so that's what we're going to do, and then we'll close off the foundation module. Okay, so let's get started. The first thing that I would like to talk about is why we cannot load a material inside of a Foreach loop, at least not from the same material node. Now let's have a quick look at a Foreach node. If I were to create a Foreach primitive node and drop it down, and let's plug in our network here from the right, then Normally, this for each loop is going to run over every single primitive in my building, and as a result, it's going to be quite slow. As you can see right now, it's running more than 30,000 loops. We don't want to do that, of course. So instead, let's go ahead and filter it over one of the attributes that we have. We can simply run it over, say, our preview material or maybe our preview material name, because each one of those has a unique material. So if we run it over every single material, that should already do it, right? Let's grab it, set it to piece attribute, and I'm going to update this one to preview material name with a lowercase m. Okay, so now this loop is running 14 loops, which is a lot more efficient. And then let's go ahead and install a QuickShade node so we can grab that address right there and assign it. So if I grab a QuickShade, let's plug it in, and let's hook up the texture map so it grabs our preview material file name and address. Okay, let's type some backticks to create a expression field inside of the string field. And then let's type prims, which allows us to load a string on a primitive, right? Then we need to assign the service node that we need to grab from. So for that we can type 0, because we are just grabbing from input 0. Then I need to specify the primitive number to load from. In this case, all of the primitives in this loop have the same material. If we were to look at just this loop, let's say loop 1, then right now we are loading the base color balcony tiles material. Okay, let's say we grab number 0, which is going to be primitive 0. And then finally we need to specify the preview material path. So I'm just going to type that in. And we need to close that with a bracket. Okay, it is loading the material and it's grabbing it from the preview material right there. So that should work. Now let's see what happens if I load a different material. Let's go to a different pass. Okay, we're now loading a different material for the concrete bar texture. And we can keep going until maybe we've gone through all of our materials, right? So let me just hide this for a second. Every one of these has its own material. However, if I turn off single pass, the entire building gets assigned a single material. Everything right now has the plaster texture. And why is that? Well, very simply, in Houdini, the shopnet and the material node inside of a QuickShade can only assign one material per node in memory. As a result, when we're viewing our textures in a for each loop, only the last texture assigned to the memory of this shopnet here, which is being loaded from that material over here, is actually going to be present on our building. Because all the other ones have been overwritten every single time this QuickShade node ran through that loop. If we want to assign a unique material to every one of these, we would have to have unique QuickShade nodes. And that means we cannot put it inside of a for each loop. And the second reason, just to put it out there, is that by putting this in a for each loop, we are actually splitting our building per material. Any mesh that had fused points is then going to be separated, because at the end all of these are going to be split, right? Every object that's supposed to assign a different material is going to split from every other material, and I don't want to do that either. We would have to refuse it, and that might run us the risk of messing with our normals, maybe fusing the wrong components together. Let's go ahead and avoid that. So we cannot use a for each loop. That's the main takeaway. Okay, so if we can't use a for each loop, then let's go ahead and set up a system that deals with one material per QuickShade node. For simplicity's sake, let's go ahead and create a subnet over here that we can start working in. So for that, let's type subnet. Assign optimized QuickShades Houdini 18.5. Let's go ahead and plug that in. And then inside this node, we now have an input and an output node. Okay, simple enough. Now the first thing that I would like to do is create a null node so I can read my data in here. I'll just call that one the input. Okay, so in order to set this up, the first thing that I would like to do is take my preview material name primitive attribute, the one that's coming from my utility nodes, and I want to prune off the extension of this file name. Now that means that I want to remove anything that comes after the dot, and I also want to remove the dot itself. And I need to do that because I want to use this part of the file name as both a group and as the actual address to assign it to, as the name of the file. So let's create an attribute wrangle, and then I'll show you how we can set this up. In order to make this work, we are going to have to remove the extension. So let's call it that. And in Vex, we can do this using a split Vex function. So in here, I'm going to set it up to primitive mode, and I'm going to type split. Now the split function allows it to take any string argument, run it over a separator, which is going to be a component of that string that will split the argument, if you will, and then it's going to store it into an array type attribute. Now we're going to have to cover what arrays actually are a bit more thoroughly, and I'll do that in a second. But let's first type this up, and then we'll see what it does. So let's say I provide it with some kind of string. Let's say mod1 dot mod2. And then I run it over its separator argument dot. If I then close the argument, then now this is a valid function. But the problem is that if I try to write this particular result out to an attribute to preview it, for example, it won't work. At least not using a simple standard string. Let's say we try to type s at test. As you can see, right now this node is erroring out. And that's because this particular Vex function cannot write out to a standard string. It can only write out to an array. Now we can define an array attribute by adding brackets behind the s. If you do that, it will write it out, and you can actually see it right down there. We now have an array type string that we can write from and read from. Now this could work, but in our case, I don't actually want to write it out to an actual attribute. I simply want to return it as a local variable. And for that, we need to type this slightly different. In this case, we can type string, let's say material, and then behind the name of the variable, the local variable, we can type our brackets again. And then that will define it as an array. If you want, you can close it off here, and that will create a local variable array called material inside of this node to be used later. You could actually write stuff into that array using the push Vex function. Every single time this is called, it will push whatever is inside of it into the array. And then you could grab the getComponent Vex function to then grab components from the array. For example, in this case, if I grab component 0 from this test attribute here, I would grab mod1. Component 1 will return mod2. But let's not go too far into that for now. In this case, I'm going to grab material and assign it using a split function. Then I'm going to type my attribute name. So that's going to be string attribute preview material name, comma. And then in the second argument, I'm going to provide a dot inside quotation marks, right? Because this is a string that we're actually grabbing. So this dot is evaluated as a string. And then we can close the expression. Okay, so we don't have any errors, which means it works. But we cannot actually see what's inside of this local variable. Now, like before, we could write this out to an attribute. So if we grab this particular attribute here, we could say array attribute test equals material. Now you don't actually have to write out the brackets if you're trying to reference an existing local variable array, but in this case this will work. Now, as you can see, we are writing out an array with tiling concrete panels 2, that's the first argument, and then the second one is PNG. And it's gotten rid of the dot because that was the separator. Now, you don't actually have to write it out to a string attribute. You could also use the printf command with, say, $s to reference a string. However, if we were to do that here and output it to the console, Houdini is simply going to print out the same thing for every single primitive, and it's going to print everything out to the console, and that's going to take a while to compute. So I could demonstrate it quickly in a different wrangle in detail mode, but not in here, because that's going to take a while. So let's say I create another wrangle. And for this, I actually have a little example. Let's grab this. Put it in detail mode, so it only runs once. And then instead of writing it out to a attribute in our spreadsheet on our geometry, let's print it out. So for that we can say printf, then inside quotation marks we can type %s to write out a string, and then after that we can provide whatever we want to add to that argument, right? So in this case that's going to be material. If you do that, the console will come up and it will show you what's inside the array. Now, if we want to grab just one of the components from the array, we can actually add brackets behind material here. If we do that and we type 0, it will give you just one of the components in the array as a simple string. As you can see, if we do the print function, it will add it behind the previous line. So if we want to send it to the next line, we can do this with \n. You have to make sure it's inside the quotation marks. And if we then click outside and at least update it once more, it will start putting whatever it outputs on the next line. And the number that we provide inside these square brackets actually determines what component of the array we sample. So if we sample component 1, we will grab material 2. So in this case, if we have material 1 and 2, that's 0 and 1, but we don't have a material 3 or a third entry, in which case it will output nothing. If we then, however, return back to a valid value, you see how it's basically just skipped a line, but it has actually added a line. So keep that in mind. You could actually print nothing at all. Now, like I mentioned, if we run this over primitive mode, it is going to output for every single primitive that is unique. And I've noticed that unless you're running this over the same value, it is not smart enough to skip repeated prints. So it is going to just print out for all of these primitives here. Like, we need to go through 30,000 of these printouts if we try to do this over primitive mode. So let's not do that right now. Let's not do that for this. Okay, so with that, we now have a basic overview of what arrays are and how we can also output them back out, right? How we can preview them. Now, at this point, we have a string that's being split up into an array of two components. The first one is our texture, and then after that we have the extension. Now, in this case, it would be very simple to just retrieve the name without the extension. We could simply create a string, a regular string, like s at preview material is equal to material, our array, and then in brackets specify element 0, right? The first element in our array. If we do that, and assuming that I added semicolon, it will now output just that part of the array into this attribute, and that will work. However, that's assuming that our name here doesn't have any dots in it. If our texture were to have any dots besides the one from the extension, it would actually split that, and then it might just only grab the first part of this texture name, in which case it would break, right? So I don't want to have to deal with that. Instead, what I would like to do is take this array and grab everything except for the last part of the array, which means that we need to remove from the array. Now that's something we can do fairly simple. Let's say we go over to the expression here. When we run a split operation, everything outside of this expression is actually considered an array. And if you put brackets behind an array, you can manipulate it. Now, if we look at the help file in Houdini, let's open that one up, and we look for array, maybe in vex, then if we look in the list of things you can do with arrays in Houdini, one of them is slicing an array. Now, when you slice an array, you're effectively manipulating its contents without using any other functions. So when we're talking about slicing arrays, we can do this in two different methods. One is by using the brackets behind or on an array attribute. And if we fill in a specific command involving a colon, then we can effectively grab the first couple of components of the array, the last few. We can even reverse the array in order, or maybe we want to grab every other character, so every odd number in the array. And basically, this is a way to do it without having to use a function. If you want to do it with a function, you can also use the slice function as well. So the slice function will allow you to do the same kind of operation, but using a more familiar method, perhaps. Now let's go back, and the type of function that I want to write here involves grabbing the array itself and then subtracting 1 from it on the end. To do that, we can type a colon and then -1. And what that will do is it will basically remove, after the array, 1 element. Now, when you do that, it will split the array, but then, before writing it out to this string value, this string attribute array, it will remove 1 element at the end. Then if I print it out, we only have 1 element remaining in our array test attribute, which is exactly what we want. Because if we were to have a dot in our name, then it will not remove the first couple of elements, only that last part, which is always going to be our extension, right? So just to show you, if I remove this again, we keep the PNG, and otherwise we remove it. Now in this case, we are writing it out as an array, so this is an array attribute, and if I want to write this out to an actual attribute down here, it would have to be a regular string, at least for our purposes. So let's create that one. Let's say s at preview material equals material. If I try to do that, it's going to error out. Because of course, while they are both strings, this is an array and this is not. So we could grab one element out of the array, like so. However, doing so wouldn't work if we have more dots in our name than one. So if we have more than 2 elements in our array, just like before. So let's create a little test case here, and I'll demonstrate what I mean. In order to facilitate this, let me create a new local variable. Let's say string testmod equals, and then let's call this one tiling.testmod.png. Let's say that's a random texture that we decided to load onto our building, and it has an extra dot in it. If I try to load this one over here into my split instead, then now we are going to have 2 elements remaining, tiling and testmod. Now, because we are removing that last element, we are removing the PNG. And as you can see, if we only grab the first element of our array, we only grab tiling, which wouldn't include the fact that this is our testmod. So that's not going to work either. What I want to do here is basically join back together all of the elements of the array that are kept after this operation is completed and turn it back into a regular string. Now we can do that using the join function. And the join function allows us to take an array and then combine it back together, basically take all its elements and put them back together into a single string. But we can also decide what we do in between these elements. So since the split function removed our dot when it did the split and turned it into separate elements here, separate components without the dot, we can add it back in using our join function. So to write the join function, we just have to provide the array. In this case, that's going to be material. And then within quotation marks, we can provide, say, a dot. So if we write this one out to our preview material instead of our material 0, then now our preview material is going to output tiling.testmod without the .png at the end, which is great, because that means our original name is maintained, but we remove the extension. Now the join function only needs an array. It doesn't need it to be a local variable, and it doesn't need it to be a regular attribute array. It could just take whatever this split function is already outputting. So if you want, you can even go so far as to put it in a single line, like this, where the first argument is our split function and our brackets, which removes a part of the array. And then after that, we can type the second argument, which is the additional join element, so the extra dot. And because this part of our code was expecting an array, we also have to correct that. First, let me just comment these out. So as you can see, it is working. This is outputting a regular string attribute. Even though our split function produced an array, our join function has turned it back into a string. And then after that, we can write it out. So let's say we do that. All right. There we go. So now it's in a single line, and that's working just fine. Now there's one thing to keep in mind, and that is that we are going to use this in combination with groups. And groups cannot accept special characters, except for maybe the underscore and the dash. Things like dots, exclamation marks, question marks, they're all invalid as a group name. And instead, Houdini is going to convert those over to underscores. So tiling.testmod testmod will turn into tiling underscore testmod. And the problem is that if we have a different name here and in our group, then our assignment system that we're going to build here, that's going to help us assign our materials. So this system is not going to work properly. Now we can do that fairly simple by just going to our join, then go to where it joins back together your independent elements of your string and turn that into an underscore instead of a dot. If we do that, then whenever it joins our individual elements back together, it is going to become an underscore. Now this will work fine if we only want to turn this into a valid group. Now there's two problems with this method for what we need it for. We need this system to create a group name, so basically one of these names here, that doesn't have any special characters in it. And the dot is a special character. It won't accept it. If you provide a dot, it will turn it into an underscore. So our system here will do that for us. But in our case, we also need it in order to reconstruct our file path. And if I go and change the group and how it is written, I will also change how the file name is written, and then it won't be able to find the file. So in here, this UVQuickshade is recombining our texture folder, our group name, and our file extension. So we need to actually do something in order to maintain our dots, even though they're supposed to be groups. You catch the problem? Let me explain this in a slightly different way. Let's say we take this example where we have our texture folder, then we have our texture name, and then the extension. So these three elements are going to come from here. Now this group here is also going to be used to assign our texture that this is assembling, our texture path, from whatever group is on the building. If we make any changes to the way how this is formulated, so if we purposely change our underscores to another character, like a dot or a dash, then as you might notice, some of our textures will simply disappear, because this is part of how the file name is assigned. But it's also part on where the texture is assigned to. We cannot change this and at the same time maintain our texture. So how do we get around that? Well, there is a way. Basically, our groups will only accept underscores, and our file, in this case, only accepts the dot, because otherwise it can't be found. What we need to do is turn our dot, or any other character that's invalid in a group, into something that groups will accept, but that can then be turned back into the original characters. And we can do that using the encode function. And encode allows us to take any non-acceptable character, so any kind of character that groups won't accept, and turn it into characters that it will accept. And then later on, we can take that and then decode it again. Now the nice part is that encoding and decoding is accepted by both Vex, Python, and HScript. So it's usable in every context in Houdini. You can encode something in Vex and then decode it in HScript, so say a group field, and it will work. So we are going to use this trick instead. So let's go back and let's switch this around. So instead of using this underscore here, we're going to encode it. So first, let's remove this underscore and turn it back into a dot. This way we make sure that whatever our original file path was, it's going to remain the same. Okay, we don't want to mess with that. Then we're going to make sure we write out our material as preview material. And then let's go and create another attribute specifically for our groups that has the material attribute encoded. Let's type s at preview mod underscore group. And then we can say encode material. If we do that, then it's going to create another attribute right there, which starts with xn underscore underscore if there are any non-valid characters in the attribute itself. So in this case, the dot is not valid, so it has removed it, and it's instead turned it into GSA, which in this case describes where that dot is located and the fact that it was a dot, the fact that it was this type of symbol. But this will also work with other types of characters. So let's say I add a couple of question marks in there, which are also invalid. And then as a result, it changes the way how the string is encoded. So in case you have any special characters, this system will make sure that our groups will accept them. Now in my case, my textures don't have any special characters in them, so we won't need this system for those. But if you want to provide any of your own textures in there, or you want to give this to an artist that may, for some reason, use dots in his naming convention, this is important to get right. Otherwise, our system will break on them. So you always want to make sure that the type of tool that you provide to your user is going to work for them. And this is one of those fail-safes that you can build in to ensure that it isn't going to break. But okay, let's go ahead and set this up so we can turn this into a proper group. For this, we can take our preview mod group attribute here and turn that into a group using a partition node. So let's drop one of those down. And let's name this one partition material name into groups. So something like that. And then inside we can provide an expression that creates a unique group for every attribute that we provided. So in this case, what I would like to do is use my preview material group over here. Let's type some backticks because this is ultimately an expression, right? We're reading an attribute. So we need to type attribute preview mod group. If you make sure that matches, then at this point, it should generate a new group for you. There we go. So now it's created our tiling test material GSA5WA, or basically our encoded version of that group name, which will work just fine for us. Now, of course, I do want it to be hooked up to my actual preview material name. So let's go ahead and change this around again. Let's clean up this code. So I'm going to remove this test material part. Then we don't need this test mod either, or this part up top. We just need this component. And then let's change test mod back to attribute preview material name. There we go. So as you can see, it is now creating a unique group for every one of our materials. However, because there are no special characters in these group names, and we did remove the .png, we didn't actually have to encode it. So encode is only going to change the actual string. It's only going to change how it looks if there is something to change. So that's something to keep in mind. But at least we know that since we're encoding this, if our material has any special characters, it won't break on it. Now before we continue, I want to make one small change to what we just did. We only need one of these two materials. Preview material and preview material group are a bit redundant. I just put them there for comparison's sake, so we can compare one to the other. Let's take our preview material group encode material part, copy that, and plug it into our preview material like that. And then we can get rid of the preview material group attribute altogether. Now if we do that, we still need to update our partition node. So over here, just change it so it references preview mod, and then that should be all good. But at this point, we've gone over enough new Vex concepts. Let's leave some of the rest for the next video. For now, let's just go ahead and install our textures onto our building. So we need to set up this material system down here. So now that we have this, let's go ahead and set up the system that we can easily copy to assign our materials one by one. So over here, we have a subnet, and on this subnet we have a group with a drop-down, so we can easily grab from that. We also have our texture folder address over here. In this case, it's just a folder path. And then we have a string parameter for our extension, and we'll need to file it in ourselves. So let's create a subnet. And I'm going to call this one material_0. I'm just going to call it as green because it is going to assign a material for us. And then inside the network, let's dive in and let's create a QuickShade node. Now, what I would like to do is I want to use this QuickShade node in order to assign our material and also grab the group that we want to assign to. Now, since this group field can already see all the current groups on our geometry, we can actually use that to assign both the material name and the group. Now let's first set up the parameters on the top of this network, and then we can copy this over. So let's go ahead and add a custom interface on this subnet. We can do that from the parameters and channels and then edit parameter interface. So we are not using the type properties interface. This is not a digital asset. We're just going to use the edit parameter interface to edit the local interface of that subnet, right? And then over here inside, let's go ahead and hide these labels. We can apply that. That will get rid of those. And then the first type of parameter I want to drop in is a file directory. So let's grab this one from over here. And let's call this one texture folder. And as for the label, we can make it something more interesting, like prefix texture folder. So if I apply that, it is going to create a folder that we can browse in. We can actually browse on the hard drive. Now what I would like to do is grab my text folder here in our current project. So under job, go to text and then accept. And that will give us $job for the current project folder /text/. I'm going to copy that, go to channels and plug it in as my default. Fairly straightforward. Okay, then next let's set up a simple string for our file extension. Let's grab a string, drop it in there. And then over here I'm going to say file extension. Now under channels, by default, I'm going to call this one .png. Those are all the files that I've provided. They're all PNG files. Now, if you want to create a drop-down for this that allows you to grab some pre-configured files, you can also go to the menu tab and then under here say use menu. Menu only single selection. You want to change that to replace field plus single selection menu. And in this case, I'm going to say .png is .png, and then maybe .jpeg, .tiff for TIFF files, right? Different type of texture format that Houdini uses, and any other type you want to support. And then we can just say apply. Now in this case, that means that you now have a drop down over here that you can grab from, and it will allow you to replace whatever extension you're trying to load. Okay, so let's set it to PNG, and then let's add the group field as well. we can grab the group field from the QuickShade node in here. So let's grab it from up here under group, drag it in here, and this will already set it up. So we actually have a group dropdown on our node. For this we can click apply, and then if we go back outside, now we're going to have a dropdown for our groups pre-configured that we can grab from. So we can say, let's assign a material to concrete panel tree, for example. And there we go. Now we select this group, it gets applied on our QuickShade, and we have it available to us as a parameter that we can grab from. Okay, so now that we have all three of these components, we can start to integrate them into our QuickShade node so we can assign our texture map. To do that, let me quickly go back up, and I'm going to grab my parameter panel for this subnet, so I can easily drag it from that, right? Let's jump back in, and then in here, the first thing I want to drop in is my texture folder. So let's drag it in, say relative channel reference, and now we should have that path set up for us. Okay, then let's grab our group over here, because that includes the name of the texture. But I can't just drag it in, because if I do that as a relative reference, it's going to override it. So I'm simply going to right click again, copy parameter, click behind, and then paste as relative reference. Okay, so that should set up this path right there. And then let's add the extension as well. Copy parameter, click and paste. All right. So now this is configured. We should now have our texture being loaded by this node. Let's check it out. And considering this is for the concrete panels tree, we just have to find that one in the building. If we want to do this a bit easier, maybe we can filter for this one. So let's grab a blast node. I'm just going to copy this path, plug it in, and say delete non-selected. Okay, there we go. So let's see if this is assigning our texture or not inside of our building. Yeah, it is. So this is working. And then there's only one last thing we need to do here, and that is to add a decode command to our group when we provide it to our texture path. Because if we have an encoded group, then this needs to be decoded, otherwise it won't match the actual name of the texture, right? That's the entire point. So let's create a little demo of that. Let's say I go out of this network, because right now we don't have any textures that are encoded, right? These didn't have any special characters, so we didn't have to worry about that. So I'm gonna have to create one for myself. Over here I have a group, primitive group, which I have provided with a backticked encode command, which is simply grabbing this string, tiling.modTest, and because the dot is a special character, it's going to encode this. Simple enough. So if I now go back and I grab that group, then now in here, if I look at my texture map at the end, it's going to try and find xn underscore tiling modtest gsa.png. That's not what I want. Instead, what I would like is for it to find that tiling.modtest texture. So I can say decode and then in my string at the end, it should now evaluate it properly. So this should work if this was a valid texture I was trying to load. Okay? So with that, we just have to get rid of this blast node, and then let's get back out of the network. And let's also get rid of this group node, because that was just a test. Okay. We can now start configuring these material nodes. So like I said, this system is hard-coded. We're going to have to set this up for every one of our materials. Now, the first one that I want to set up is for the first entry, our balcony tiles. So let's set it up to that. However, our dropdown just added a second group to the field instead of replacing it. This will only work for one group at a time, one material at a time, one group at a time. But that's fine because this node here, our partition node, is already dealing with that. And we don't have any primitives that have two materials, okay? They can't have it. They can only have one material. So we just need to make sure it is one line, like that. If we have that, then now it should assign our balcony material. There we go. So let's copy this subnet. And I'm going to paste it below. And I'm going to assign the second material. Concrete bars in this case. Now, if you don't want it to do that, you can also go into the subnet itself. Let's go to the edit parameter interface. Go to group. And I'm going to say, instead of multiple selections, I'm going to set it to field plus single selection menu. And this should allow it to only accept one entry, not two. I'm going to accept that. And now if you go and select another one, it's only going to replace it, not add it. This will mean that this one hasn't been updated because, like I mentioned, the interfaces are unique. So just to make sure we don't accidentally copy one that has a wrong interface setup, let's also update this one. Okay. Just keep in mind, these are not actually digital assets, they are just subnets. Okay, and subnets are not instantiated. They're not loaded from a HDA, they're just there, like a node. Okay, so let's copy this one and let's start setting up all the other materials. So for every one of these, that's the third entry. You can also go ahead and copy the entire batch if you want to be a bit faster about it. And we'll just start setting them up one by one. That's number 4, 5. Then we have concrete panels. Then I'm going to copy this network again. And as you'll notice, because I named them with numbers, they should auto number, right? So number 6 is going to be concrete wall. Number 7, granite floor tiles. 8 is going to be polished concrete. 9 is going to be the red brick. Then roof gravel. Roof panels. And then we need one more, at least, for the okay. So that's all the materials assigned in Houdini for Houdini 18.5. And at this point, this should work, except we do still need to actually hook up this path here, our texture folder path, to the interface, because we do actually have a texture parameter over here that we can set. Let's see, it's over there, texture folder. So I'm going to copy this parameter, grab all of these material nodes, and because they're all selected and they have the same parameter name, we can just replace it here. So right click, paste relative reference, and that should have assigned it on all of them. All right, so now it's hooked up properly. Let's go to the outside and let's connect it up to our network. Okay, so at this point we have our materials reintegrated, at least for the Houdini 18.5 version. And that means that if we go to the end of our network and we just have a quick look at the tool, then everything should be restored. We should have all our materials assigned, and that's great. Because that means we now have an optimized system that also has all our materials assigned properly. However, like I mentioned, this system is hard-coded and it's not properly synced. We have to actually manually sync our materials, because if, say, we load a different material somewhere in our network that isn't in our drop-down list, or that we haven't configured on our end node, like let's say we load a different material, you have your own custom material, then you will also have to go to the end of the network and update that in here. Maybe add that material in here, add another copy, because otherwise it won't be able to find it, right? It's not in this list. If it's not in that list, then it won't be able to find the group and it won't be able to find the texture. Now, like I said, this is a bypass to make sure that it works in Houdini 18.5. So I'm going to go to the end of the network here, and I'm going to save the tool. And just to make sure everything is still working, let's go over to Unreal, go to our asset, and I'm going to load the foundation building tool. So let's re-import that and rebuild. And assuming that we didn't break anything, the tool should still be working in Unreal. I don't see a reason why it wouldn't. Okay. It looks like my parameters were reverted back to default settings, but other than that, the tool is still working. So if I want to, I could set this back to 14 floors, and that should work. Okay. So at this point, we're pretty much done with this video. I mean, we did cover a lot of VEX in this video, and in the next one, I have a bit more to come. However, at this point, we have a fully functional texturing system in Houdini that works even with our optimizations in place. Even with our loop, we still have materials at the end of our network. So technically, we're done, right? We could stop here. But I actually want to go a little step further and create that more automated system that I mentioned before, that auto-assigns our textures, basically to bypass that 18.5 bug, right? Because this one still works the same way, except it can actually work with the file path string that we were trying to use at the beginning, right? This one. Now, this is not too hard to set up. However, what I do want to do in the next video is have a look at how we can also check if the texture that we're trying to load, the file we're trying to load, actually exists. And there's an easy way to do this, but there's also a more advanced way to do this. And for this, we are actually going to look into a bit more VEX code, including some external libraries for VEX that ship with Houdini but aren't loaded by default, so we can actually check some of our files. And while we're at it, I'm also going to show you how we can set up a basic debug system for our console that's going to tell us the status of our texture, what type it is, and then if it's valid or not. Plus, we have the ability to specify what type of extension is valid, meaning if we don't specify it, it will accept all types of extensions, or we can tell it only accept, say, JPEGs, in which case it won't find it and then it won't tell it it's valid. So we're going to write a little bit of logic for that, and we'll do that in the next video. For now, thanks for watching this video. I have a lot more VEX to come, especially in the following modules of the masterclass, and I hope you look forward to that. And we'll be diving headlong into this stuff. And if you want to know more, feel free to join my Discord channel. And it also helps a lot if you leave a like on this video or leave a comment or subscribe, right? It all helps out the channel and it all helps me push out more free content like this. If you have any other questions or if you want to show off your work, please join us in the Discord channel. I'm always there to check out what you guys have made. And yeah, with that, thanks for watching this video, and I hope to see you in the next and last video of the Foundation module. Have a good one.